Absolute, maximum and minimum. Here is probably the most popular question which you'll come across. A piece of wire 100 centimeter long is cut into two pieces. One piece is bent to form a square and the other is bent to form a circle. Determine how the wire should be cut so that the total area enclosed is a maximum or is a minimum. Okay, so this is a very interesting question and I think the most important in this playlist. Now let's try to see how to do these kinds of questions. Let's assume that this is our wire which is 100 centimeter long and it is cut somewhere, anywhere in between, right? And let's say this is x, then that portion will be 100 minus x, since the total length is 100 centimeters for this wire. And now let us assume that with this length of x we make a square, and with this length of 100 minus x we make a circle. Now the question is, what should be the value of x so that we either get maximum area of these two combined or minimum area? So that is the question, right? Now in this problem what we need to find is, if we have this length of x, then what is the area of square? And if we have this length of 100 minus x, then what is the area of circle? Now, as far as the square is concerned, if the length is x, then each side length will be x over 4, right? So each side will be x over 4. And therefore, what is the area of the circle? Area of the circle will be x over 4 square, correct? Because those are all equal sides. Now, in the case of circle, so we can write this first, right? So area of square, let us say square, is x over 4 whole square. So that's the area of our square. Now what is the area of the circle? Now area of circle is pi r square, but we don't know what is the value of r. Now we need to find the value of r. But we know the perimeter is 100 minus x, correct? So 100 minus x can help us to find the value of r. So we know here that 100 minus x is equals to 2 pi r. That is the perimeter of the circle. Now this equation can relate r with x. So in terms of r, we can write what is x and then later on solve equation in one variable. So we can from here write that r is actually equals to 100 minus x divided by 2 pi. Correct? So now r is 100 minus x divided by 2 pi. So we know r, and therefore we know area of the circle, which is pi r square, right? Now let's go back to the question. What do we need to find? Says a piece of wire 100 centimeter long is cut into two pieces. So here we have two pieces. Length of one piece is x, the other one is 100 minus x, since the total length is 100 for us. One piece is bent to form a square and the other is bent to form a circle. Determine how the wire should be cut so that the total area enclosed is a maximum, right? So what is the total area? So let's say total area is A, right? In that case, A is equals to area of square, let me say AS, plus area of circle, let us say AC. Now as you have seen, if x is the length of the wire for a square, each side will be x over 4, 1/4. And therefore, area of the square will be x over 4 whole square. How about area of circle? So we found that if 100 minus x is the perimeter of the circle, which is 2 pi r, then r is 100 minus x divided by 2 pi. And area of the circle is given by pi r square. So pi r square, right? So area is pi, area of circle is pi r square, right? So we'll substitute r with this value. So we'll write r as 100 minus x over 2 pi. Do you see that? Whole square. So that is pi r square. Do you get it? So that is the area. Now we have equation in ax. Do you see? So now we have a function area in x, the length of the cut wire. So one variable. So we did all this exercise to get this function in one variable. Now to find maximum or minimum, we need to find critical points. So critical points are a couple of ways. One, we have a boundary condition here. So what is the boundary condition? Let me write it down here. The boundary condition is that x has to be greater than or equal to 0 and cannot be more than 100, right? Because 100 is the total length. So that is my boundary condition, right? So we have critical points which we'll calculate here by finding a dash x equals to 0, and then we have boundary conditions to compare our values with. And then we'll find absolute, maximum and minimum. That is the strategy. So let's find the critical points first. So a dash x is equals to derivative of this. So this derivative will be 2 times x over 4, right? Or you could actually expand it and then do it, but we'll do 2 times x over 4 times derivative of x over 4, the inside function, which is 1 over 4, correct? At times students find this difficult. Then in that case what you can do is, you can open the bracket and then you get x square over 16. So derivative will be 2x over 16, the same value which we are getting here. Now I have applied the power rule of a function, okay? Now here again I'm using the same rule. So we have derivative of this 2 times, so we have 2 pi times the function, which is 100 minus x over 2 pi times derivative of this function, right? Now the derivative of this function is minus x over 2 pi, correct? Because derivative of constant is 0 and derivative of minus x over 2 pi is minus 1 over 2 pi. So it is minus 1 over 2 pi. So that is what you get as the derivative of this. Now if you're finding this difficult, first open the square and then do it, correct? So either way you get the same result, right? Now here let's simplify it as much as we can. So 2 will cancel out with 1/4, so you get 2 here, so you get x over 8 plus. Now here what we can do is we can cancel out 2 pi with 2 pi, and so we get minus here. So we have, okay, so we will interchange this with minus. We'll multiply 100 with minus and x with minus. So we get, in this case, x minus 100 over 2 pi. Correct? The 2 pi cancel, but we are still left with 2 pi here. Correct? And 100 minus x times minus 1 will give me x minus 100. So that is what I get as my equation. Now the critical point is when a dash x is equal to 0. So let's figure out when is it 0 to find critical point. So we are trying to find critical number here, right? So to find critical number, a dash x equals to 0. So that's what we did. And now let's solve for this. Now to solve for this, let's multiply everything by 8 pi, right? So we'll do times 8 pi, everything, correct? So when you do this side, you still get 0 here. So you get 0 equals to, when you do by 8 pi, you get x pi, right? Let me write, pi is a constant, let me write pi first, pi x. Now in this case, you have to multiply by 4. So you get 4 times x minus 100, correct? And then we multiplied 8 pi, so we get rid of denominator at this stage, correct? Now this equation boils down to pi x plus 4x. So we got the x terms, which is, we can write this as 4x plus pi x. And let's open this up, minus 400. So that is the equation equal to 0, right? And now we'll try to solve this equation to find the critical points. So when we solve this equation, we can take x common, right? So we get x here, and we have 4 plus pi. minus 400, we can take it on this side, so we get equals to 400. And from here, we can get the value of x, and x is equals to 400 divided by 4 plus pi. So that is the value of x, which gives us the critical point. And let's figure out how much this is. So we'll do 400 divided by, within brackets, 4 plus pi, bracket close, equals to 56.009. So we'll just write this as 56. So for x, the length equals to 56, we have a critical number, right? Now we have a critical number, which is x equals to 56. We have boundary conditions, which is 0 and 100. Now what we need to do is find the value of the function, which is right here at these 3 points, right? So if we plug this in here, what do we get? And then comparing the values, we can say which one gives maximum and which one is minimum for us. So let's plug in first 0. So we have a0 equals 2. So if I put 0 here, what do I get? That is what you have to calculate, right? Now if I put 0 here, you get first term is 0, x is 0. The next term will be 100 square over, so here we have x0. So we have pi times, now within bracket, 100 square, 100 over 2 pi whole square, right? So that is what we get. So we can calculate this value. So we'll divide 100 by 2 pi, square it, and then times it with pi and get the value. So that is 100 by 2 is 50. So we'll just do 50 divided by pi. I know we could have, equals to, and we'll square this number, equals to, and then we multiply by pi itself. So which is equals to 795.77. So we get this value as 795.77, right? Now let's find the value at, 56. That is a critical number. So A56. Now in this case, we will do 100 minus 56 within the brackets, right? Divide by 2 pi and then square it, correct? So we'll do 100 minus 56 equals to, and we'll divide by 2 and divide by pi, and then we'll square this number, and then we multiply by pi. We get 154.06. So we get 154.06, and then we'll do a at 100. So if I write 100 here, in this case I forgot to add this value. So A56, I have to add this also, correct? So I just calculated this half. Let me calculate x over 4 square also for 56 and then add it to this. So we'll do 56 divided by 4, which is equals to 14, and square of 14 is 196. So this is this plus 196. So we have 196 plus 154, which is equals to 350. Yeah, so this is 350 for us. Correct? So I forgot to add this term, right? Now for A100, we have to put 100 here. So 100 divided by 4 is 25, and then 25 square is 625. So let me write 625 here. Now, and if I put 100 here, then that becomes 0, right? So we get 625 here. So 25, yeah. So we get these values, correct? So if you compare these values, what do you notice? So clearly the maximum value for us is this, and the minimum is this, correct? So that is the maximum value. So the answer therefore is determine how the wire should be cut so that the total area enclosed is maximum. So it should not be cut. The whole wire can be used as a circle. Do you see that? If the whole wire is used as a circle, we get maximum area, right? So in this case, we were cutting like this. So we say 100 centimeter for circle gives maximum area, right? And the area is approximately 795.8 square centimeter. Now the minimum area you get when the wire is cut into two pieces, and one of them is 56 centimeter long, right? So it should be cut at, so for minimum area we have 56 centimeter for square, and the rest, which is 100 minus 56, which is 44 centimeter for circle. So that is the way it should be done, and probably the most efficient way it can be done. So you'll come across this problem so many times. The idea here is, first see the scenario and then figure out one variable to work with. As we did here, we assumed x to be the length of the square, and so the balance was for the circle, and then found the area of both circle and square in terms of x, correct? And then found the derivative, critical numbers, and checked the values with boundary conditions. So that is how it should be done. It's the most important question in the whole playlist. I'd like you to go through it. Do the questions, do the calculations yourself. I nearly lost this value. Do you see that? And in these maze of numbers, you can always lose some of them. So therefore, practice for your test. This is 75% chances to be in your test paper. Thank you and all the best.